Hi, this is Zheng Chen from UMass Dartmouth, and this video is going to be the demonstration of the outcome UMassD accomplish model module GUI, which is the ODE solver for ODE initial value problems of ODE. So this module is designed to help the students develop a GUI, which is like application by using MATLAB. And this application is good for selecting ODE solvers to solve initial value problems for ODEs. And the students will be provided with, let me see. So this is the folders that will be available to the teacher, to the professors. And there are going to be two folders. One is for the one is for the director, for the professor that's going to advise the student, and you will have the full files of everything, including the APP file and also the subroutine files with everything coded up. And then the other folder is for the student, and the APP file is accomplished, is finished. So the students are not required to do anything here, but for all the subroutines, which are like for each solvers, ODE solver, the student will have to fill in the blank after they learn what the algorithm is, and they will fill in the blank so that this app will run completely. So that's how this works. And along with these two folders, I will provide this demonstration video and also another video talking about the details of all these solvers, like how the solver looks like, what need to be filled in, and what is the algorithm, and some details there. So that's how it looks like. And in this video, I'm going to demonstrate what the outcome looks like. So once the student fill in the blanks of all these M files, they can open this APP file with MATLAB, and let me use this full version. So suppose student have finished everything, they should have these files coded up, and if they double click on this ODE solver app.ml app, you will see the MATLAB will open this window. It's the app, it's the GUI. So the students can put in, this is ODE problem, the derivative of y, how it change with respect to t, equals to some function f, which is a function of y and t. So for example, if the right-hand side function is y minus t squared plus 1, and you want to solve this problem from t equals 0 to t equals 2, and by the way, those values can be changed, so you can use another function, right? And also for this initial value problem, you need to fill in the initial value. Suppose we use 0.5 for this problem, and then you have several things to choose from. For example, you can choose ODE solver like forward order. And once you click on that, there's a new option to show up that will give you the freedom to choose how many time steps you want to solve this ODE solver, right? It's like how many times you want to take, how many steps you want to take from 0 to 2 to get this ODE solved numerically. So by default, it's like 100, which is very enough for this case. And you can choose to be like 400, or you can just see how it looks like step by step by choosing a very small number like 4, right? So something like that. So once you finish everything, if you click on solve, the solver will run in the background, and you will see the results of the simulation on the right-hand side in this plot area. And for that plot, you can choose the color. So by default, it's blue. You have also other options like green, red, black, right? So suppose we choose blue here, we click on solve, and this is the result you have. So the x-axis, the t-axis is the time, and the y-axis, the vertical one, is the y value, which is a solution of this ODE problem, this FAP problem. You can see it looks like this. So let's choose a small number for number of time step, say 4. By the way, you can yeah, let's click on this first. Then you get another result, right? So you can 1 step, 2 step, 3rd step, and the 4th step as the last time, the final time, right? So you can see there's the option here, do not plot over old answer. If you click on that and you click on solve, the previous plot will be erased and you only see the current one. So if you choose not to click on that, uncheck that, and you choose a different color, say you use 100, you can compare the two run, right? So the second run with 100 number of time steps, you can see the solution is more smooth compared to the one with only 4 time steps, right? So this is a way you can compare between different number of time steps for the same solver, or you can compare with different solvers. So for example, let's remove this. So we just keep the forward order with 100 time steps. And let's choose another one, say range cutter method of order 4. Let's choose a different color, say black. And then we click on solve. Okay, you can get another one, which is like a very good, how to say that? They match on very well, right? So let's choose different one. Oh, I click on do not plot, so we only see one. Let's choose the forward order and click off this one and check that one, and let's see the comparison. Okay, you can see a slight difference, right? So they are not going to give you the same results. Suppose we want to compare forward order, which you will later find out is a first order method, with Taylor method. Say we have second order here. We choose a different color. We use red for that. Anything? Oh, okay, yeah. You can see they probably match up, so you can see only one line. So let's use 4 time steps that will demonstrate better. And let's choose red again for Taylor of order 2. Okay, so this is the result for Taylor method of order 2. And then let's uncheck that to compare the 2 solutions. Forward order, we use blue. Then we get, okay, you see the forward order will give you this answer. The blue one, the Taylor method of, sorry, I zoom out, accidentally zoomed the plus. Okay, so the red one is a Taylor method of order 2. And also you can choose other order like 3. Let's choose a different one, use green. Okay, so you can see order 3 is green, is also slightly different, right? So this is like how you use this app to solve ODE problem. You basically fill in the problem here, the function of the right-hand side of the equation, the range, the initial value, and then you select the solver, and also some plotting, some variables that you can put in for the solver, and also you can choose the number, the color of the line in the plots. And also you have the freedom to try to compare different solutions or just look at one, right? So that's how this works. Another thing is, if you look at the list of the ODE solvers, we have forward order, we have Taylor method with the option to put in the order. We have second order range cutter, 3 of them. The midpoint method, the modified order method, the Hume method. We have range cutter method of order 4. And also we have several 1, 2, 3, 4, 5, 6. We have 6 the MATLAB built-in functions. So this is just for the purpose that you want to use this app later on for other problems, right? So they're like the built-in one, and students are not required to change this. So this part is okay. But for the other methods, the previous 1, 2, 3, 4, 5, 6, the students need to fill in the blank, the key sentence in the code to finish this app. So that's how this app looks like and what the student need to do. To to see the code, oh, there's some outputs, that's okay. So to see the codes, or if you really want to see how the app was designed, you can use the design app here. So if you look at here, we have home, we have plot, we have apps. You click on the apps, you click on the design app, and the design app will show up. There's a start page. You can open the file to choose this one. You can use in the open file button here to open that one. Since I already opened that, so I just click on the recent file. And the Open Designer will open that file, and this is how it looks like. So let me make it smaller so I can see the whole thing. Okay, even smaller. Yeah. So in the middle part, that's what the file will be. So you have two views: the design view, which you see everything here. You can just click on each part to see the content there, right? Something like identifier, those things. And so for example, we choose the solver here. You can see we have values. You can change the value here, right? That's how you change that through this design view. And also you can look at the code in the background for that app. So it will look like this. The students are not required to touch anything here, but if they want to, for example, put in more solvers, they have the freedom to do so. So what you can do is you here, you can add more solvers later on, right? You can add those. And then in the code part, you need to add more case here. So if you add one more in the item list, and that will be case 14, and then you call the corresponding solver for the one you add, right? So that's how you expand this thing. And if you want to change other parts, so let me remove the change I have made. So if you want to change this GUI, how it looks like, you can just work on this design view, or you can work on code. And in the lecture, in the other video, I will give you the resource, like some videos to understand how this works. It's not that hard. It's okay, I think. So that's the freedom. The students can add more solvers and they can play with this. If they don't like this sentence, they can remove it afterwards. I don't mind. Yeah, so that's how it looks like in the code science. And well, you can see that the key part is here. So once you choose from the list, like which solver you want to use, it will run into this part. So basically they will find the identifier and they will figure out which one to call. And for example, if you choose Taylor method in the drop-down list, it will come into this one, K3, and they will call this function. And by the way, the function here is actually going to call this function here, this file. The function is written there. So let me open that. Yeah, by the way, they all need to in the same folder, so it will run successfully. Yeah, I don't want to show the. Okay, so this is how the function look like. You need to call this function, and they will go through the sentences here, the code step by step, and then they will return all the time steps and also the function's value. I mean, the simulation results at those time steps. So that's how it works. Yeah. So this is how the module looks like. And in the other video, I will talk more about those methods that the students are required to fill in. So I will talk more about methodology and how the numerical methods for ODEs will look like. Okay, that's it.